relate this to fractions, and I know that people kind of hate fractions, but if you think about it in terms of fractions, it's really not that bad. So this one, let's label what we know. This is 0. And notice it's just a circle, and I just kind of put a coordinate plane right through the middle of it. What measures over here? Pi. What if we broke this circle? Right now it's in 4 equal parts. Do you agree with that? Yes? What if we broke this into 8 equal parts? Did I do that? Just kind of slice through the middle of each of these? Yes? So let's kind of do that. Let's kind of slice through here, slice through here, slice through here. Well, you know. It would have, but... So think about this top half for a minute. In terms of pi, if this from 0 to here is pi, how much is each one of these little segments going to be in terms of pi? Pi force, do you agree this would be like 1 pi force, 2 pi force, 3 pi force, 4 pi force would add up to pi? Yes? Those are those measures of those angles. So if you cut halfway through the middle of quadrant 1, guess what? That's where pi force is, which is the same as 45 degrees. If you go up here, that's 2 pi force, but how do we write that? We don't write 2 pi force. It's alright, it happens. And then if you just keep counting, how much is all the way over here? Pi force, 2 pi force, 3 pi force. It's 1/4 away from pi, or 3/4 of pi. 3 pi force. And so hopefully you can start thinking about that when I give you a radian value. Oh, 3 pi force is just a little 1/4 away, or pi force is 1/4 of the way around. What if we keep going here? I can still count by force. If this is 1 whole pi, or in force, that would be 4 pi force. What's this going to be? 5 pi force. Right? That's bigger than 1 whole pi. It's like 1 and a 1/4 of pi. And what's this going to be? 6 pi force, which we could reduce to pi halves. And what's the next one going to be? 5 pi force, 6 pi force, 7 pi force. And what do you get when you go all the way back around? And is that the same as 8 pi force? So one angle that we use a lot is in terms of pi force, and that's actually in terms of 45 degrees if you change it to degrees. So knowing those are really kind of very important, especially as we get closer to this whole unit circle thing. So hopefully that maybe makes some sense there. What are the other angles that we use a lot? 30 degrees and 60 degrees. That's in terms of pi sixths. So let's think about, let's cut this from 0 to pi into 6 equal parts. So I think that would be roughly like right here and right here, right? That would roughly, I'm a little off. A little bit bigger. And then right here, and roughly right there, would be kind of like 6 equal parts. And we're going to do this at the bottom too, so we should end up with 12 equal parts. And I'll see if I can take Logan's advice this time. It's probably not going to work out so well. Oh, I failed art class. Oh, that's not No, I didn't. I didn't take art class. I took ceramics actually, so you don't have ceramics here. We had ceramics 1, 2, and 3. I didn't have anyone that didn't have any teeth in my school either, just so you know.
I don't believe that.
Just saying. And we didn't say Monday. Again, think about just in terms of pi when you're doing this. If you're going from 0 to pi and you break it up into 6 equal parts, how much is each little section? Yeah, it's 1/6 of pi. So this is pi sixths. And if you know that first one, you just count by sixth every time. If this is 1 pi sixth, how much is this?
2 pi 6.
And could we reduce that fraction?
Yeah. 1/3.
This is pi thirds. Those are our other two important angles, 30 degrees and 60 degrees. And we can just keep counting here in terms of 30 degrees. So 1 pi 6, 2 pi 6, what would this be? 3 pi 6, which is still going to reduce to pi halves. What's this one going to be? 4 pi 6, and then I'll write this up here, but I'm just reducing these fractions. Divide by 2, so do you agree that that's the same as 2 pi thirds? And if that makes sense, that's 2/3 of the way to pi. What's the next one going to be? What's 1/6 the way from pi? Yeah, 5 pi 6, because 6 pi 6 would be pi itself. Well, this is important. Do you want to have to convert to degrees every time on a no calculator part of a test? So this would be the same as 6 pi 6, so what's this going to be? 1/6 past pi would be 7 pi 6. This would be, that's terribly drawn line there, but that would be 8 pi 6, which I'm going to reduce to 4 pi thirds. This would be 9 pi 6, which is still 3 pi halves every time, but I just want to show you can count by sixths. What would the next one be? 10 pi 6 is going to reduce to 5 pi thirds. And 1/6 away from 2 pi is going to be what? 11 pi 6, because again, think about 12 over 6 is 2 pi. And so when you are given those values, think about, is it bigger than pi? Is it close to 2 pi? To kind of think about where those are. But every time, if you break those up into sixths, or 12 equal parts for the whole circle, then those are our other important angles. Eventually, in a couple days, we're going to put both of these angles together, like all this together into one circle, and talk about what the unit circle is and what we do with it. But these angles are super, super important. We can. It gets a little messy, but yeah. So today, what are we doing with these angles? Well, instead of just looking at a triangle, what if we looked at a point on a circle and we asked what the sine, cosine, and tangent were, and we need to talk about how can we do that? It's going to be a little bit different than SOHCAHTOA. Maybe. Some angles, at least. No, this is not a number one. This is more like formula here. And then we'll get to number one. So again, we're still talking about finding these trig values, but instead of just giving you a triangle, we're going to go back to the idea of looking at angles. And so it says, let theta be an angle in standard position with a point xy on the terminal ray of theta. And r equals the square root of x squared plus y squared, which cannot equal 0. We're going to draw a little picture here so we can see what that means. Terminal ray is where it stops, right? The initial ray is where it starts. So if I'm going to draw this, I'm going to draw one here. I'm going to just draw it in quadrant 1 this time, but this will be my initial ray. My terminal ray is where that stops, and I'm just going to draw an angle up here in quadrant 1. Why not? Well, no, I'm just trying to draw a picture for what this is saying. They don't tell us what theta is, so you could really draw theta whatever you want. But this would be my angle theta. Yes. They're telling us that theta is an angle in standard position. And they're telling us that on the terminal ray, there's a point xy. So I'm going to put a point here, and I'm going to call that xy. Basically, what we're going to do is we're going to make a triangle out of the angle that they're giving us using that point. So if I had that point xy, could I draw a line? I'm going to put a dotted line here. If I drew a line straight down, would that make a right triangle every time? Given any angle, a point on that terminal ray, you could draw a straight line down, and it would always make a right triangle. So it's kind of like we're taking those right triangles and putting them into a circle. And I want to show you the ratio of these sides. If this is the point xy, how long is this segment at the bottom? X units, do you agree with that? And how long is this side going to be? I totally missed there. Every time. Whatever y is, so this is going to be y. And if you use Pythagorean theorem, do you agree that the hypotenuse, which we're going to call r, because we're going to call it the radius of the circle, do you agree that r would be what they tell us here? We would take x squared plus y squared and take the square root of it. So that's where this comes from. It's just Pythagorean theorem. It's not like something special you have to memorize. So what we're going to do is talk about how can we write sine, cosine, tangent in terms of x, y, and r instead of thinking about opposite and adjacent. But it's the same ratio. If I was going to do sine of this angle theta, which is down here, what's the ratio for sine using SOHCAHTOA? Opposite over hypotenuse. Using the circle and using x, y, and r, what's the opposite side going to be? And the hypotenuse we're calling, which means if they give you the point, you don't necessarily have to draw the picture every time. You just need to know what x, y, and r are, and then you can plug them in. And again, just flipping it over, I'm going to go ahead and give you the reciprocal at the same time. Cosecant would be r over y. We do maybe need to say that cosecant could be undefined on this because y could be 0. So we would say that y is not allowed to equal 0 or be undefined. We don't have to say that over here because r is never going to be 0. The hypotenuse is always going to be something. We'll talk about that more in a minute. So we can do all these. Hopefully you know that cosine is adjacent over hypotenuse. Using this picture, what is the adjacent side going to be? X, and the hypotenuse is still going to be r. So that means the secant, we could flip it over and say that's r over x, where x wouldn't be allowed to be 0 or it would be undefined. And we can do the same thing with tangent and cotangent. Normally we think of tangent in a triangle, we think of it as opposite over adjacent, but in terms of the point on the circle here, opposite would be y, adjacent would be x, so that would be y over x, and probably we should say that x couldn't equal 0 or that's undefined, because x and y could be 0, right? Like what if I was at the point, we're looking at some examples of this, if I was at the point 0, 7, and you try to take 7 divided by 0, it's undefined, which means there is no tangent at that point. We haven't done that yet, because we've always looked at these lovely triangles where no side was equal to 0. But in the coordinate plane, one of the sides could be 0, which means it's undefined. And we'll look at some. So I'm just writing it out for now. Cotangent would be, what? Flip it around, x over y. And we would need to say y should not equal 0. So today we're just going to kind of practice this. It's not super awful to do, but I want to show you how you can do it and how maybe we'll draw a picture, but then maybe how you don't need to draw a picture for the second one. Okay? Can I go? Same idea, just changing it to X's and Y's. Again, we're getting closer and closer to that unit circle idea. And this is what your homework says today. They don't give you a triangle. They give you an ordered pair. It says, let the point negative 12, 5 be a point on the terminal ray of theta. Find the following values. And probably on your homework it says find all 6 values, maybe. Yeah, we don't know where theta is. We don't need to know where theta is, really. Because if they give us the point, we're going to know how far to draw that angle, right? So I'm going to kind of draw this just to show you, but then we'll talk about, did you really need to draw it to do this? I'm not going to make a super accurate graph, but if this is my ordered pair, do you agree that I can figure out where my point is on my terminal ray by just graphing the point negative 12, 5? And again, you don't have to make 12 marks on your graph, just kind of do a general area. Negative 12, could I just make a mark over here and say this is negative 12? 5, I'm just going to make a mark right here and say that's 5. So if you wanted to draw the picture like I did on the first one, find that point, negative 12, 5, and that's going to be the terminal ray of your angle. You see what I'm saying? If you want a picture. Here's the thing, you don't really have to have a picture, because what do you need to do these? You need X, you need Y, and you need R. We already know that X is negative 12. We know that Y is 5. And could I find R without ever drawing a picture? Because I know that R is always going to equal the square root of X squared plus Y. Or X squared plus Y squared equals R squared. But not in this, no, because we're in the coordinate plane, which means you have to take the sign that's with it. Okay, the sign really does matter, because, again, think about what we've done so far. We've only done what you did in geometry class, which means I've only given you triangles that had positive sides. All of our trig functions have been positive. Nothing's been undefined. Now we're taking that idea and we're putting it in the coordinate plane, which means sometimes sine's going to be negative, and sometimes cosine's going to be negative. Sometimes tangent's going to be negative, because it's going to depend on where you are in the circle. Everything we've done so far has been nice little cute triangles in quadrant 1. But we could have a triangle over here, or down here, or over here. And so you can get some negative numbers. So you have to take the sign that's with it. It's the same formula, right? If you just do this, do you agree you're going to get the same answer? It's just solve for R, so you don't have to take the square root, like, of both sides. I promise you'll get the same answer. Whatever you want to do. I just used the one that's solved already. When I plug that in and square it, do you agree it's always going to be positive? Yeah. So that would be negative 12 squared, or 144, plus 5 squared, which is 25. This one's a really nice one. It works out as a perfect square, but just like the ones that we did already, if it's not a perfect square, do not give me a decimal. Simplify that radical, leave it as a radical. This one you get the square root of 169, or 13 is R. So again, the picture's great. If you want to draw the picture, you can. Notice since we're in a different quadrant, our triangle kind of comes from a different spot. Your triangle would come from dropping down the side there. This would be my radius, or my hypotenuse. This would be the length of negative 12. This would be a height of 5. But you get all that from here. So that's why if you know the ratio, you don't have to draw the picture, because sine is always going to be y over r. So if you know that, there's no need to draw a picture. So in this case, I would say sine of theta is 5 over 13. And that would be my answer for sine. If you don't know the ratio, that's where you'd really want to draw the picture, and you could still use SOHCAHTOA. It works the same way. What about cosine? Yeah, it's x over r. This is an example that there's a negative x value. So if x is negative, my cosine is going to be a negative value. It's going to be negative 12 over 13. And same thing for tangent. It's just knowing that ratio. And in the coordinate plane, tangent is y over x. And so we would say tangent of theta equals 5 over negative 12. Just like always, it doesn't matter on this answer if the negative was in the top and the bottom. As long as you put a negative there, it means that it's a negative value. And you could do secant, cosecant, and cotangent. I'm just not going to waste the time doing it because you just flip them over, right? So because we're now talking about all four quadrants, I want to go through and show you how you can figure out what the sign, like positive or negative, of each trig function is in each quadrant, just based on whether x or y is positive or negative. So let's look at that next. Kind of just you don't have to make a huge one here. We're just going to write sine, cosine, and tangent in each one of these. So make sure you leave enough room that you could write sine, cosine, tangent in each quadrant. And I'm going to label my quadrants here. 1, 2, 3, and 4. Remember that we label quadrants with Roman numerals. Probably just so it doesn't get confused with the other numbers that you're putting in a coordinate plane. And since sine is y over r, and cosine is x over r, and tangent is y over x, you can figure out whether your trig functions will be positive or negative without actually figuring it. And this is something that on your homework today it says, what is the sign of this, without calculating it. Obviously, I can't stop you from using a calculator at home, but on a test I could. I could give it to you on a no calculator part, so you want to kind of know this. If I look at all ordered pairs in quadrant 1, what are the signs of x and y? Is x positive or negative in quadrant 1? Positive. And what's y in quadrant 1? Positive. So if you look at the sine, cosine, or tangent of any angle in quadrant 1, you can figure out whether it's going to be positive or negative. And again, just think about the ratios. I'm going to write this over here just to remind us. Sine is y over r. Cosine is x over r. Tangent is y over x. If sine is y over r, is sine going to be positive or negative in quadrant 1? Because y is positive. Can r ever be negative? No, because it's Pythagorean theorem, it's always going to be a positive number, so r is always going to be positive. You're just looking at the y and the x. So sine is always going to be positive in quadrant 1. I didn't put the reciprocal functions, but if sine is positive, do you agree its reciprocal function is going to be the same as it? So we don't have to write that. What about cosine? Cosine is x over r. So look at the sign of x. Positive. And tangent is y over x. So if you have a positive over positive, it's going to be positive. This is what we did on our quiz yesterday. Everything was a positive answer. You didn't get any negative answers because everything was less than 90 degrees. Okay? So let's look at the other quadrants now. What is the value of x in quadrant 2? Is it positive or negative? It's always negative. And what about y? It's always positive. So if we look at our three main trig functions here, every time if you are in an angle in quadrant 2, you should be able to tell me whether sine, cosine, or tangent would be positive or negative without actually doing any work here. Because sine is y over r. If y is positive, do you agree sine is still going to be positive? I don't know why I put equal sign there. It doesn't really equal anything. But what about cosine? The one we just did was a negative angle for cosine because it was in quadrant 2. Because x is negative. You're going to have a negative over a positive. It's always going to be negative. And do you agree tangent's going to be negative also because a positive over negative is always going to equal negative? 3, what are the signs? If they're both negative, x is negative and y is negative. So what does that mean for sine and cosine? Yeah, sine is y over r, so a negative over a positive is going to be a negative. Cosine is the same as quadrant 2. It's still going to be a negative over a positive. But what about tangent in quadrant 3? Because a negative over a negative is a positive. Right, and if you have a negative over negative, it's going to always equal positive, right? You with me on that? And quadrant 4, what are my signs for x and y? Yeah, we're back to positive side for x, but we're still down here on the bottom of the y-axis, so negative for y. And again, you're just looking at the sign of y and x here. Sine is y over r, so if y is negative, sine is going to be negative. Cosine is x over r, so x is positive, cosine is positive. Tangent, since these are different signs, it's going to be negative again. So I want to point out here that every trig function is positive in 2 quadrants. Do you see that? They're all positive in quadrant 1, but every quadrant after that, only one trig function is positive. This is going to come into play a whole lot more as we get into solving trig equations and doing a bunch more things with trig equations. But that's definitely something that you're going to want to be aware of. Is there a need to memorize this? No, because if you know the sign of x and y, the sign as in plus or minus, you should be able to know this. But I just wanted to kind of give this to you. On your homework today, what are you going to do with this? You're going to answer questions like this. Determine the sign, positive or negative, of the trig function without using a calculator, which means I don't want to know the answer. I don't want to know the value. I just want to know, am I going to get a positive answer or a negative answer based on what quadrant I'm in?
That's for the radian.
And that's where if you are able to figure your radians, that's going to be helpful. Can you convert? Yes. Can you convert without a calculator? Yes. You can do some arithmetic. But if you become familiar with those trig functions, those radian values, you don't have to do as much work. Yeah, the degree ones are pretty easy, hopefully. 299 degrees. Yep, I think it's quadrant 4. This is 180, right? And if you ever forget what this one is in terms of degrees, what would you add to this to get this one? You add 90, and I believe it's 270 degrees. So 299 is definitely in quadrant 4. So then the next question is, in quadrant 4, is cosine going to give you a positive answer or negative answer? And think about the ratio for cosine. It's x over r. So in quadrant 4, is x positive or negative? So I could say the answer is positive. Maybe write out the word positive. So again, that would show up on a no calculator part of a test that we would have. Because with a calculator, you can just type in cosine of 299 degrees, and it's going to give you a positive answer. And obviously, you would say positive. But that's where I can give you some more no calculator problems. 2 pi thirds, you definitely could convert that to degrees. But think about what we talked about, or just think about 2/3 of pi, where that would be. If this is pi, 2/3 of pi would be like over in here, right? I think so. And so again, start thinking about these as fractions, and think about how much of the circle that would be if the whole thing is 2 pi. So that's definitely in quadrant 2. Again, you can look at the chart I gave you for your homework today, but what you want to start thinking about is the ratio for tangent is y over x. So in quadrant 2, are y and x the same sign, or are y and x different signs? They're different, so that means it's going to be a negative.
We don't have that chart. We have to write out. We have to think of like so, and you have to think of like.
Well, I mean, like, this is how I would do it on a test. Just like this. I mean, there's no need to write that whole chart out because you're just thinking about, are the signs different or the same? You see what I'm saying? I mean, you could write that whole chart out if you want, but I feel like that would be a waste of time to do. Questions about that? I think that's all my notes today. That's ridiculous.
What's on the homework?
This stuff.
Right here.
And the stuff, the point stuff. Like what we did first, like the negative 12.5, giving an ordered pair, finding sine, cosine, tangent. That's the main stuff.
4-3 day.
This is 4-3 day 1. And you're doing 3 through 12 multiples of 3. I think those are the given a point, find R, and then find sine, cosine, tangent, maybe even the other 3 trig functions. And then 17 through 20, I think, are mostly which quadrant, or which is it positive or negative. And we're going to keep adding on to this. And so this section is kind of really, really important. It kind of puts everything together. So please do your best to stay up on the homework. Also, this is the last section we're doing before our first test, which means you want to make sure you stay caught up on the homework for that as well. So you actually have some time to work, like 10 minutes, maybe even 12 minutes. So everyone get started, so in case you have a question that I can help you.